Up and running. All right. This video, I'm going to call it a useful quadratic exercise. Meant to do what? Meant to help you see the numerical, equational solving processes, to develop a few connections, synapses, pathways, so that what you're working with, you might be able to understand at a deeper level. So let's have at it. I'm going to take you through a little exercise, and then we'll get a little feedback. And in a week or so, as you play with these concepts, and we'll see if it leads us in the direction of a stronger algebraic foundation from which to leap into higher level mathematics. All right, so open parentheses, you get to put the number in that works. All right, so what do you put in there and square it to get 43? For each of these, you pause the video, you take your time, you look at it, and you try to answer the questions that are in front of us, okay? And I'm guessing that most of you got this one wrong because I'm guessing that most of you forgot to write plus minus. I wonder how many of you remembered the plus minus. Something squared equals 43, x squared, right, equals 43 has got a positive side and a negative side, and you got to show that. Okay, so now we're going to try to do this one, and you're pausing the video. 2 times what squared equals 39. I hope you remembered the plus minus, and I hope you know that, you know, the square root of 39 squared is 39 times 2 is twice the size we really need. So we got to figure out a way to undo this. Of course, squaring comes first, right? So I hope you landed on 39 over 2. And when you plus or minus, squaring the square root of 39 over 2, you actually get 39 over 2. And what happens to the 2's? They cancel. Hence a correct response. So now we're doing it with a negative, and you're pausing the video. You're saying, okay, what do I need? Well, if you said plus or minus the square root of negative 57 over 5, you're well on your way to a correct answer. But we don't express numbers like that, do we? No, we take the negative out and we do what? We write the letter I. All right, so now when I square plus or minus, I get a positive. When I square 57 over 5, I get 57 over 5. The 5's are going to cancel, leaving 57, and I get I squared. And what is 57I squared? Well, we've been looking at that. It's negative 57. So now we're doing this one. 7 times what minus 3 squared equals 19. So you're pausing the video. I'm just going to keep going. Ah, well, I know I got to get square root of 19 in here. I also know that if I'm multiplying by 7, I got to get a 7. I also know I got a plus minus. And the only thing standing in the way right now is minus 3. So I guess I got to get rid of that too. So what happens to the 3's? They cancel here. What happens to the plus minus when you square? You get a positive. What do you get when you square the square root of 19 over 7? You get 19 over 7. And when you multiply that positive 19 over 7, by golly, you get 19. Kind of an organic thought process here. Let's see if you can solve that one. Pause the video. I think, if I'm looking at this correctly, I got to get rid of the 5. I know I got a plus minus. I got to get negative 11 out of this thing, so I got to get rid of this, right? So it looks like I've got to get minus 2 out of the equation. And I want to get minus 11. Let's see if that works. So if I square this, well, the 5's disappear. If I square that, I get 11 halves. And if I multiply that by negative 2, I seem to get negative 11. So I don't think we have any imaginaries here because a minus into a minus. So I guess we'll divide that out right now and see if this works. Oh, the 5s go. I square this, I get 11 halves. I multiply by -2. Sure looks like we get the number we want. And I guess the most complicated one is the last one. So what happens if I wanted positive 11? Well, I gotta get rid of the 5. I know I gotta get positive 11. Oh, okay. Back to the plus or minus. I know that's gotta happen, right? And I know I gotta get rid of this. Kind of looks like I got an imaginary answer. Let's see if that works. Get rid of the 5, square root. That gets me 11/2. But I squared gets me that. And I'm going to multiply by -2. Oh, that's a -1. So that's really a minus. And a minus times a minus is a plus. And 2's cancel. Yeah, I get 11. Okay, so we just did a little work for a reason. Because now I want you to write this quadratic in graphing form. But I don't want you to put anything there. I want it in an open space. As Alicia says, we're going to do some loading up there. We're going to do some loading. Okay? I'm going to throw some stuff in the trash too. New vernacular. I can't believe I'm saying these words. But it does seem generational. Got the trash can. We got that. Go ahead. Do the problem. Pause it. All right, I'm back. So, looks to me like -4, -7. We could immediately write +4 -7. We've been practicing that in class. So the only thing we got to do is find the A term. How do we find the A term? We take the change in X and square it. And if it doesn't work with -7 to get me 41, we throw it in the trash. And then we load up the fraction with the number that does work. New language for me. Can't believe I'm saying this. Over 4 to 0, right? -4 to 0 is over 4 units, but we're going to square that. We're going to get 16. -7 to 41 is 48 units of change. We need to go up 48 units of change. So 16 plus 4 squared -7 doesn't take me there, so we're going to get rid of that. Right? We're going to get rid of that because it didn't work. But 48 does. Yeah, 48 -7 does. So when I put in -4, let's put it in here. -4 plus 4 squared, well, that's 0. 0 times anything is 0. -7, I guess. Looks like a quadratic, and certainly 0 squared is a minimum. And by plugging -4 in, that's certainly the smallest number you can get out. So we're at a minimum. That's good. Now let's put 0 in. 0 plus 4. Oh, 16. There, after you square it, right? 16 divided by 16. That's a nice number. 1 times 48. 48 -7. 41. Looks like it works. And if I tried to put other dots here and, graph the quadratic, boom, 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 well, that's not this graph. If I tried to go through that one, boom, 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 that's not this graph. I guess it's unique. So let's call that 3. We're really doing a little tripling. And if I wanted to go up one more, then it wouldn't be 16 over 48. It would be, if I wanted to get to 42, it would be 49 over 16, a little more than tripling. Okay, but right now we did tripling. Okay, let me get rid of some of the stuff here that might visually get in the way of the discussion we want to have. So we did a little work over there, and I guess I'm asking you what the roots are now. -7, well, I think they're down here. I think that's a height of 0. That's the x-axis, right? Ooh, that was a bad rotator cuff. I wonder if I can go up here and see, what makes a 0? Pausing the video. And I hope that you're looking at this and going, oh, I got to get rid of addition of 4. I guess I got to have -4. Boy, that seems like it's centered here. Yeah, looks like I got to have a plus minus, yeah. And I guess from -7 to 0, I got to go up 7 units. So I guess there's a square root of 7 in here. But because I'm tripling the squaring process, I guess we just found our roots. -4 plus or minus the square root of 7/3. 7/3 is a little bigger than 2. Square root of 2 is 1.41. I don't know, maybe 1.5-ish. 4 plus 1.5-ish. -4, sorry, plus 1.5-ish is what? -2.5. Got a root near there. -4 minus, I already forgot what I said, 1.5 minus 5.5. I mean, this is the y-axis, right? X equals 0 is the y-axis. Does it look like what numbers we said? I know I said 2 negatives. Seems appropriate. I think it works. So what do we have here? We have 3 times x plus 4, was it? Squared, yeah, -7. And we're going to expand that right now. 3 times x squared plus 8x plus 16. I hope you're following because we practice this now, right? And so what was your function? Your function was y equals 3x squared plus 24x, 48 minus 7, 48 minus 7 plus 41. Oh yeah, that was the y-intercept when you put a 0 in. Very nice. So now we're going to put that in graphing form. You use your technique. I'm going to show you a little shortcut. It's the fastest way I found to do it. All the patterns, but you do your little thing. And if you pause the video now, and okay, you're trying it. Unpause. Back to me. Okay, I'm hoping you did the minus b over 2a thing. If you didn't, pause the video. You try it. Yeah, that was a little hint. Okay. And if you understand that and you want to even do it quicker, here's the quickest way that I know thus far. All right. Actually, because I'm on a board, I get to erase some things and make life a little easier for myself. All right. So I know we got that. That's automatic. I wouldn't even write that. I'd bring that in later because I just want to keep going from left to right. They're both the same sign. When they're both the same sign, you get to write a plus. If they were both negative, you get to write a plus. When one's negative, one's positive, or one's positive, one's negative, you get to write a negative. So now I don't have to worry about the minus b over 2a. I just got to divide 3 into 24, 8. Boom, divide it by 2. Then I can put a 2 here. Now, what I do in my head is I throw a 0 in, because I know a 0 gets me 41. And if a 0 doesn't get me 41, I get rid of the number, I throw it in the trash, and I write in a 41. So 0 plus 4. 4 squared, 16 times 3, 48. Did 48 take me to 41? No, 48 didn't work, so I throw it in the trash. What did work? 41. Of course, I do that in my head. And what's minus 48 plus 41? Minus 7. I guess I'm done. I guess that's in graphing form. Oh, yeah. If we get rid of this number and we put x here, right? Looks to be the same thing. Wow. Now, what would you do if you wanted to solve for 0? And now you have this. Well, I think you'd put a 7 over here, right? I think you'd divide it by 3. I think you'd undo squaring with a plus minus. And I think you take positive 4, make it -4. Okay. So if you can find the a term, and you can find the vertex, you got a quick way of finding the roots, real quick way. And maybe a deeper understanding of the quadratic formula when we prove it using this method. Okay, and we'll do that later in the term. Oops, I got a call. Got to stop the video.